In this video, we are going to discuss much more about conservative vector fields. So, let us begin our class with a theorem. This is called as conservative field test. Conservative field test. So, let us first of all understand what does this theorem states. So, in this theorem, f is given to be a conservative function on some open region D, where small f and g are the components of capital F. So, if small f and g are continuous and have continuous first partial derivatives on some open region D, and if the vector field f of xy is equal to f of xy I plus d of xyj is conservative on D, then the theorem states that dou f by dou y, that is the derivative of the partial derivative of small f with respect to y, will be same as the partial derivative of g with respect to x at each point in D. Conversely, the converse of this theorem also holds true if the region D is simply connected, which means that uh, uh, simply connected means a region without holes. So, if D is a region without any holes, if it is simply connected, then if dou f by dou y is equal to dou g by dou x, it means that the function f of xy, the vector field f of xy is equal to f of xyi plus g of xyj is a conservative vector field. So there is a conservative field test. It is actually a characterization. When will be a vector field? When will it be conservative and reverse? What should a conservative field must follow? I hope that the theorem is clear to you. So, on briefly, if f is conservative, then dou f by dou y is equal to dou g by dou x, and on the reverse, if the region in which f is defined is simply connected, and if dou f by dou y is equal to dou g by dou x, then the vector field, the corresponding vector field will be conservative vector field. So that's about this particular theorem. Now let us move on to an example. Let us move on to this particular illustration. So, in this, we are asked to determine whether the vector field f of xy is equal to y plus xi plus y minus xg is conservative on some open set. So, since open sets are clearly simply connected, they are regions without holes. What we need to check is that we need to check whether dou f by dou y is equal to dou g by dou x. So, since the region is simply connected, if dou f by dou y equal to dou g by dou x, then by the previous theorem, then by this conservative field test, f will be a conservative field. So, here f of xy, small f of xy is equal to y plus x, and uh, g of xy is equal to y minus x. So we need to calculate the partial derivative of f with respect to y, dou f by dou y. So dou f by dou y, dou y of y plus x. So what is the partial derivative of y with respect to y? It will be equal to 1 plus partial derivative of x with respect to y. It will be equal to 0. So this is equal to 1. Now we need to calculate dou g by dou x. Dou g by dou x is dou by dou x of g of xy is y minus x. This is equal to the partial derivative of y with respect to x, that is 0, minus the partial derivative of x with respect to x. It is equal to 1. So this is equal to minus 1. So from this, what you can observe is that here dou f by dou y is equal to 1, which is not equal to minus 1, which is equal to dou g by dou x. So what you can conclude is that here dou f by dou y not equal to dou g by dou x. Dou f by dou y and dou g by dou x does not agree. So this means that the vector field the vector field F is not, F is not conservative. That is a thing that you can observe. I hope that this is clear to you. So now let us move on to the next problem. In this problem, here the vector field f of xy is given. So here we have small f of xy is equal to 2xy cube. This is small f of xy, and g of xy is given to be g of xy is equal to 1 plus 3 x square y square. So in the first sub question, we are asked to show whether the show that f is a conservative vector field. So you should prove that f is a conservative vector field on the entire xy plane. See, the entire xy plane is in fact simply connected, because if you consider the entire xy plane, it does not have any poles. So it means that xy plane is simply connected. So all we need to, by conservative field test, all we need to check is that whether dou f by dou y is equal to dou g by dou x or not. If dou f by dou y is equal to dou g by dou x, then it simply means that f is going to be a conservative vector field. So let us calculate dou f by dou y. Dou f by dou y. Dou f by dou y is the partial derivative of 2xy cube with respect to y. So 2x is a constant with respect to y. The derivative of y cube is 3y square. So altogether this is equal to 6xy square. Dou f by dou y is equal to 6xy square. Now what is dou g by dou x? Dou g by dou x is equal to the partial derivative of 1 plus 3x square y square with respect to x. What is the partial derivative of 1 with respect to x? It is equal to 0 plus the partial derivative of 3x square y square with respect to x. That is 3y square is a constant with respect to x. Derivative of x square is 2x. So again this is equal to 6xy square. So from this we can observe that dou f by dou y is equal to dou g by dou x, and moreover xy plane is simply connected. xy plane is simply connected. xy plane is simply connected. So this means that the vector field f is conservative. F is conservative on the entire xy plane. So we are done with the A part of this question. Now let us move on to the B part. So in the B part, it is asked to find a function phi, and in C part also you are asked to find a function phi. In two methods you are asked to find the function phi. The first method is you have to integrate dou phi by dou x with respect to x, and the second method is to integrate dou phi by dou y with respect to y. So now let us look on to what does this mean. Since we have already told that since the vector field f is a conservative vector field, we have proved that f is conservative. That we have done on the A part of this question. Since f is conservative, what is if a vector field is conservative means what? So by definition, there exists a scalar function phi such that f is nothing but the gradient of this scalar function. This is the definition of a conservative vector field. So this means that there exists a scalar function phi satisfying the property that the vector field f is equal to the gradient of the scalar function phi. But what does del phi means? Del phi is dou phi by dou x I plus dou phi by dou y j. But we already know that the vector field F is 2xy cube I plus 1 plus 3x square y square j. This is our vector field F. So, on equating F and the components of F and L phi, on equating the components in the direction of I, we get dou phi by dou x is equal to, it will be equal to 2xy cube, and dou phi by dou y, this is equal to 1 plus 3 x square y square. Okay, so now let us look on to this. We have obtained dou phi by dou x and dou phi by dou y. We actually want to, the actual purpose is to find the function phi. It is asked in the question, so we have to find the function phi. So there are two methods you see here. We have dou phi by dou x. So how will you get, you are given dou phi by dou x. So how to get phi from dou phi by dou x? So it is as simple as just integrating phi dou phi by dou x with respect to x. So if you integrate dou phi by dou x with respect to x, the output will be the function phi of xy. And similarly, if you integrate dou phi by dou y with respect to y, then also the output will be phi of xy. So all you need to do is to integrate phi x, either phi x with respect to x or phi y, dou phi by dou y with respect to y. So let us start from the first thing, that is, so this is going to be the answer to the B sub question B. So integrating dou phi by dou x with respect to x. So for what we are integrating, what is the need to integrate dou phi by dou x with respect to x? For, because we need to find the function phi. So integrating dou phi by dou x with respect to x. So integral dou phi by dou x with respect to x, this is equal to same as integral dou phi by dou x is 2xy cube dx. Here 2y cube with respect to x, 2y cube is a constant. So 2y cube we can take it outside, integral x dx. So this will be 2y cube into x square by 2. Okay, I hope that this is clear to you. So we obtained so integral dou phi by dou x with respect to x, this is equal to 2y cube into x square by 2, that is x square by cube. Now see, there will be a constant of integration always. So along with x square y cube there will be a constant, but since here we are treating y as a constant, that will not be just not a normal constant, the constant will be a function of y. So what you get is that the integral of dou phi by dou x with respect to x, that is in fact phi of xy, this will be equal to x square y cube plus some function of y, since y is a constant, we treat y as a constant. I hope that this is clear to you, this particular portion. Now we have to find, here the k of y is unknown, so we have to find k of y. So we have obtained phi of xy. Now you just differentiate this phi with respect to y. This obtained phi with respect to y. So differentiating, we get dou phi by dou y is equal to dou by dou y of x square y cube plus dou by dou y of k of y. So dou by dou y of x square y cube, that will be x square into dou by dou y of y cube, that will be equal to x square into 3y square plus what will be dou by dou y of k of y, k is a function of y only, so it will be k dash of y. So we obtain dou phi by dou y as x square into 3y square, that is 3x square y square plus k dash of y. This is dou phi by dou y. But already we knew that dou phi by dou y is equal to 1 plus 3x square y square. This we already this particular thing. So we already know that dou phi by dou y is equal to 1 plus 3x square y square. That is that is what it happened in this equation. 3x square y square plus k dash y is the dou phi by dou y obtained from this particular in this particular way, and this will be same as this particular dou phi by dou y. So equating these two, what you obtain is that k dash of y is equal to 1. K dash of y is equal to 1 implies that the derivative of a function is equal to 1. So this means that k of y is equal to, integrating 1 with respect to y, it will be some y plus some constant k. So k of y will be y plus some k. So in effect, what you obtained is that phi of x comma y as it was x square y cube plus k of y, but we obtained that k of y is y plus some constant. So this is phi of xy obtained by integrating dou phi by dou x with respect to x. Okay, I hope that this is clear to you. Now let us calculate dou phi by phi of xy by integrating dou phi by dou y with respect to y. We know that dou phi by dou y, this is equal to 1 plus 3x square y square. This is going to be the answer to the C part. So what you are going to do? You are going to integrating dou phi by dou y with respect to y. So what you get? Integral dou phi by dou y with respect to y. This is equal to integral 1 plus 3x square y square with respect to y, and this is equal to integral 1 dy. It is equal to y plus integral 3x square y square with respect to y. So 3x square is a constant. 3x square, derivative of y square is y cube by 3, plus there will be a constant of integration, and as earlier, since x is a constant, we treat x as a constant, the final answer will be a function of x. So it will be some function of x. So here what you obtained is that integral dou phi by dou y with respect to y is phi of xy. You obtain phi of xy to be y plus 3x square y cube by 3, that is x square y cube plus some function of x. As earlier, we already know that, so you just calculate dou phi by dou x from this particular expression. So dou by dou x of y, it is equal to 0, plus dou by dou x of x square y cube, it is equal to y cube into 2x plus dou by dou x of h of x, it is equal to h dash of x. So this is equal to 2x cube y cube plus h dash of x. But we already know that dou phi by dou x is equal to, we have already written that dou phi by dou x is equal to, it is equal to 2x y cube. So equating this to, this is, so equating 2x y cube plus h dash of x to 2x y cube. That is a thing that we have done here. So in this particular, here they have taken it as k dash of x. I have taken it as h dash of x. That is the only difference. So 2xy cube plus k dash of x equal to 2xy cube. So from this, what you obtain is that you will get. So from this we get that h dash of x is equal to 0. The derivative of a function is equal to 0, which means that h of x will be some constant, say k. So we obtain phi of xy to be, it was y plus x square y cube plus h of x, that is y plus x square y cube plus h of x is some constant k. So this is the phi of xy obtained by this particular method, and in the previous slide phi of xy was x square y cube plus y plus k. Here also it was phi of xy is equal to x square y cube plus y plus k. So in both methods we are obtaining the same scalar function. and this question is to understand how these two methods work. I hope that this is clear to you. So let us wind up this particular session.